Hi, this is a short series of videos that's going to help you to revise or check that you've understood most of the things that we went through in the first 3 weeks in Java. Um, this is the Java, it's called a complete tutorial for IB. I made it kind of to your specification for the course, and it links together with this, which is the first steps in Java challenges. So you can go backwards and forwards between the two documents, and it should explain how to do things in the challenges as you face them. Okay, so I'm going to jump forward. One of the first things that we learned about was primitive variables. Remember, primitive variables, there are 8 different types. That's them on the left-hand side here. And most of them are either whole numbers or decimal numbers. There's a couple of other funny ones, but let's deal with those first. An int is the main one that we will use, and it's a whole number. But if you want a slightly larger number, which occupies twice the size of memory, you can choose a long. Now there are other whole number types. There's a byte and a short, which are significantly smaller. The byte only stores values from -128 to 127 positive. Not used very frequently. Similarly, a short from -32,768 to +32,767. Now, I'm not looking for you to remember those exact numbers because you'll be able to calculate those numbers later on when we do binary arithmetic. You'll be able to calculate them by the size of the bits. So I'll show you how to remember that later on. But what I do want you to know is for these different types, what might they be used for? So let's go through quickly. Normally we'd use an int for whole numbers, a long for larger whole numbers, a float for normal decimal numbers, and a double for very, very large decimal numbers with extreme levels of accuracy. Okay, now the other 3 that are left, a byte is not used very frequently, but it could be used for if you're storing a huge amount of very small numbers, because then it would save space. I mean, if you've what we call an array, if you have a huge array of very small numbers, you would use this because it would save storage space. I'm talking about if you're storing thousands of numbers. A char, this is one character, and it's used internally inside the string class. It's what makes up a whole string, an array of these chars. Each one is one position in the string. But if you just want to store one letter, it can be useful. And the final one is a boolean. This is used very, very, very frequently. And if something can be yes or no, true or false, it only has 2 possible states. Generally, we would try and use this because it's very, very handy and very neat when you see it in code. Okay, a variable needs to be declared and then initialized. Initialized means you give it a value for the very first time. You assign a value for the very first time. Declaring is when you say what type the variable is. And initialize is when you give it its very first value. So if you look at these examples, only 3 of them are initialized. You see the equals after it. It's given a value, this is given a value, and this is given a value. That means that these 3 variables are initialized, whereas the other ones are just declared. See that? Float int val, int ret val, double gamma. However, these are also in the same line as int. So these are also declared. So this variable here has been declared. This variable has been declared. This variable has been declared and then initialized. This variable has been declared and then initialized. This variable has just been declared. This variable has been declared and initialized. So you may need to look at a couple of different ones and tell me which combinations, whether something has been just declared, initialized, or whatever. In certain situations, Java will allow you to use a variable even if it's only been declared and not initialized yet. And those circumstances are, for example, if you declare a huge array of those values and you don't need to do every single one. So for example, if I have a massive chessboard which is 500 spaces by 500 spaces, and I store a variable in each one, a structure like that, I store a variable in each one of those, a number. Then I don't necessarily have to set them all to 0. Java will do that for me. But let's just imagine now that if you don't initialize these, Java will give you an error, because that's what's going to happen in 99% of the cases, okay? So last look at this, declarations. This is an integer and it's been set to 1.2, so that will give you a compiler error. That's wrong because an int is a whole number. This is a boolean, a true or false, and it's been set to 1, so that will also give you a compiler error. This is a double value, which is a long decimal value, and it's been set to two whole numbers, two integers, one divided by the other. Now this will not give you an error, but the answer is going to be a bit strange, because whenever you divide a whole number 5 by a whole number 4, the result is going to be in a whole number as well. The result is going to be 1, because 4 goes into 5 once. That would be the whole number answer. And so therefore 5/4 is going to be equal to 1, which is not what you expected. The proper way of doing it would be if you divided 5.0 by 4.0, and then the answer would be 1.2. Now another way of doing that is, instead of just putting those values in there, if you define a double variable as 5 and a double variable as 4, and then divide one by the other and put it in here, that will also give you the correct answer. It's only when you're using direct values in code like that that you need to be a bit careful. You can also put an F after the value, which tells Java this is definitely to be stored as a float. So you might see that in code sometimes. I'd advise you just to do it with decimal points. Final one as well, just so you remember, a float is accurate to about 7 decimal places and a double 15. And finally, assigning the variables. If you want to, you can do something like that, or you can even do something like that. Just to kind of work this out from left to right. If A is 1, B is 2, and C is 5, then if I work out this statement from left to right, A is equal to B, so A is now 2, B is equal to C, so B is now 5, so that would become 2, 5, 5. It's a bit of a trick question. I don't think you'd ever get that in an exam. Okay, I'd like to look at keyboard input. This is one of the very first things that we did. And it's in the Java challenges from the very start. If we look at the Java challenges, or the first steps in Java, the very first one asks you to input their name and print out your name is followed by their name. So it asks you to use a string and keyboard from the very beginning. So this should be pretty clear to you by now. Now there are a couple of different ways of doing this. You can use different classes to get keyboard input, but the scanner is generally accepted to be the most flexible and the most commonly used one, and it's better used inside Eclipse, because sometimes Eclipse, because it's a program which is running in Java, sometimes it has errors with the other ones. So everyone recommends that you use Scanner in 99% of the cases. Just if you're interested, other classes that you can use are console, buffered reader wrapped around system.in, but don't worry about that for now. You have to import it at the very beginning, or else Java will give you an error. Also, you have to create a variable of the type scanner. I've just called mine keyboard here so that I remember what I'm dealing with. And you have to make a new scanner because it's an object, and you have to pass into its constructor system.in. Now, you don't need to remember exactly what that means. You just need to type that line for now. When you come to actually get a value from the keyboard, there are 3 main functions that we use. Keyboard.nextLine will return a string. Keyboard.nextInt will return a whole number. And keyboard.nextFloat will return a whole decimal number. Now there are some others as well. If you press full stop after the variable keyboard, it'll give you a full list. But these are very handy, because not only do they trap errors, and you don't need to write any specific, what will happen if someone types in an X instead of a number. It'll handle all of that for you. And you can also use the scanner class for other things, which we'll be learning a little bit later on. Java uses the same maths operators as a spreadsheet, which is going to be handy for you if you ever used a spreadsheet. There's the dividing sign is a /, the multiplication is a star. The only strange one you may not have come across is a percentage, which gives you the remainder of a division. So down here, if I say 5%2, that means give me the remainder of 5 divided by 2. So the answer would be 1. And there's a handy function, other ways of doing it. If you're storing things in an int, that will work anyway, as you found out in Java challenge number. Let me jump back. the Java challenge that you started to do this was step number 2, I believe, where you had to give the, that's it, step number 3, the division and the remainder, where you had to give the remainder of a division. If you say math.floordiv 5, 2, that will give you the number of times that 2 goes into 5 with no remainder, so that will give you 2 back. Okay, so that's another another handy thing to know. That frequently comes up in exams, and it's called the modulo, which we'll do a little bit later. Of course, Java has a lot of other math functions in the math class. For example, to the power of, if you want to raise something to the power of something, square root. It's got absolute value, minimum, maximum, sine, cosine, tangent, everything that you want. You can investigate that, and indeed you probably will, because your maths teachers are going to ask you to do a little bit of programming later on this year, which is great. But to be honest, programmers don't use all of the different possibilities in the math class very frequently, and there are additional maths classes you can add into for all sorts of more advanced stuff. We're just going to look at the main stuff for now: maximum, minimum values, square roots, absolute values, perhaps, but definitely to the power of, square root, and these two, floor division and the remainder of a division. This is very handy, by the way, if you want to find out if something is an odd or an even number. You percentage 2. In other words, you find out what the remainder is when you divide it by 2, and if that's equal to 0, then it's it's an even number, and if it's equal to 1, obviously it's an odd number. It's quite handy. Also, getting a random number. There are 2 ways of doing this. There's math.random, so it's part of the math class, but this is an old-fashioned way of doing it. And then there's a new class called random.nextInt. Now, the old way, you'll see it in code all the time. The new way, which just came out in the last couple of years with Java 8, I believe, is a truer way of getting a random integer number. Because if you remember when we talked about this a little bit, although it's not on your syllabus, the old method tends to not give 0 as often as it should. Okay, so this is the way math.random will be used. If you wanted to calculate a range of numbers, say between 0 and 9, you'd say int, because you need to convert into an int. Remember, math.random gives you a number between 0 and 0.9999999. So therefore, you would have to multiply it by a number to get it to whatever range you want it to, and then convert that into an int. And that would approximately give you the value of 0 to 9. Of course, 0 would appear much less frequently than the other numbers, because int rounds down. So therefore, don't worry about that. We don't use math.random as much now, and we use random.nextInt, which is the new method. Here's a practical example. This is how I would generate a roll of a dice, which could give me a random number between 1 and 6. I would start off by importing the class, same as scanner. Then I would create a new generator, same as scanner. And every time I want to use it, I would do something like this: int number, and then I would use generator.nextInt6, which gives me a number between 0 and 5. So I just move that up a range, the whole range up 1 by adding 1. So the number between 0 and 5 that would give me, I add 1 to it, and that random number becomes between 1 and 6. Okay, making decisions in Java using if statements, etc. There are a couple of ways of doing this. The main one that we're going to cover now is if statements, which can mean if else, and if else if, else if, else if as many times as necessary, and then else, or using a switch statement. So this is the way an if statement works. You can do it all in one line if you want to, but I would advise not to, because it's not very clear, and this will only work if you're only doing one thing as a result of this condition being true. You see that? But first of all, let's focus on the brackets. The condition that you put in to be met has to be covered in brackets, has to be surrounded in brackets, or else Java will complain and it won't let you compile. I would prefer if you wrote your if statement like this. So if inside the brackets you have your condition, then you open your curly braces and put in a series of commands, one or more commands, things that happen if it's true, and then you close your curly braces. In this presentation, there are help buttons from this point onwards. This will link you directly to a tutorial about what this is talking about. Okay, so now a bit more complicated here. I've set x equal to 1, and I'm saying if x is less than 10, do these 3 things. That's fine, that will work absolutely fine. If I had not put in those red curly braces, then it would have done the second 2 things no matter what the value of x is, because the only line which depends on x being less than 10 would have been the first line. So that's why it's very important to have these curly braces at the start and at the end of your block in an if statement. Inside the condition, you can use all sorts of operators. Remember that a double equals is very different to a single equals. A double equals is comparing 2 things together, which is what you should be doing in an if. A single equals gives something a value. So it's a big error. If you say a single equals inside a brackets, Java will not warn you. Java will just make that variable equal to whatever value you put in there. Exclamation mark equal means not equal to. And you can join these together with ampersand to ampersand, which means and, or vertical line, which means or. Now the vertical line, the one I'm talking about, is directly above the backslash key on the right hand side of your Mac keyboard, below the delete key. So it's shift and backslash. Here's another option in your if statement. You can say if something is true, open your curly brackets, do whatever and close it, else, and open your curly brackets and close it again. And this gives 2 options. It either gives something to do if that's true and something to do if that's false. This is when there are only 2 possible options in a situation. This is what you would use. However, there may be 3, there may even be more. So what you can do is you can have your condition, then what to do if it's true, and then else if, and another condition, and what to do if that's true. And if you wanted to, you could repeat this. You could say else if, and another condition, and what to do if that's true, else if, as many times as necessary. And the final one, if you want to, you can add an else with no condition in it, which is what will happen if none of the above prove to be true. So this has you covered if you want to do something with a lot of different possibilities. You can also have ifs within ifs, which makes it really important that you put these curly braces in. Generally, programmers try to avoid this, but in some conditions it can be very handy. For example, one of the ones that we may use this in, or might have used it in already, is in challenge number 10, in the rock, paper, scissors, where to optimize the choices, you may have put in an if within an if. For example, if the computer chooses rock, then within that, if the player chooses rock, within that, if the computer chooses paper, if the computer chooses scissors, and if the computer chooses rock, instead of doing all the possible combinations. So jumping back to this again. Okay, another warning that I would give you is use the curly braces appropriately if you can. Yeah, always count that you've opened and closed the same number of times in curly braces, and check that if you are doing a nested if, try and indent it correctly so you understand what's going on. Now another thing is if you're using a string inside your condition, make sure that for a string you use dot equals instead of equals, because a string is not a primitive variable, and therefore you need to use one of its methods to check whether it's the same. Now we'll discover why a little bit later on, but very important. A lot of people say, you know, string 1 equals string 2, and that's not correct. It's not going to give you the right answer, and it's not going to give you an error when you compile it either, because it means something different that we'll discover later on when we do OOP. Okay, finally, string. The string class has lots of handy stuff in it. Here's a nice one. Equals ignore case will will return true for these two strings, even though they've got different capitals and lowercase letters, which is quite handy. Final thing that you'll find very, very handy if you have a huge amount of options, and if they all depend on one simple primitive variable like this, is the switch statement. Switch statement starts off by inside the brackets you put what the condition is, simple condition, and you put a series of case statements and possibly a default at the very, very end. Each one has to have a break at the end of it. But can you see that if I had 100 different values of n and I wanted to do a different thing for each one, this would be a much neater way of laying out my code than doing it with if, else if, else if, else if, else if, else if 97 times. This would be much neater and much easier to understand. Remember, please, to put the break at the end of every line, because if, for example, 2 or 3 of these could be true for your variable, for example, if this case was less than 2, then and n was equal to 1, and you didn't put the break here, then it would do the first case, it would print out n is equal to 1, and then it would go on to evaluate the second case, which may be true as well, and it would print out n is equal to 2, which would be wrong. Okay, let's look quickly at strings and manipulating some text. We should remember by now that a string is made up of an array of chars, of single characters, single Unicode characters. Now, Unicode means that the character is quite complex. In other words, it can be from any language in any character set. Previously, in computing, we just had ASCII, which had American standard characters, and there were 127 characters and no more. And that was quite limited, because you can imagine trying to use a different language or a different an Asian character set or any other non-Romanized character set. It was impossible. So therefore, Unicode was invented, and Unicode is now the de facto standard, and it's got a huge amount of different replaceable code sets or code pages that you can have. For example, people have created characters for just about every language, and there are even some pseudo fake languages in there like Klingon, which is invented by Star Trek enthusiasts, but it's all available, and it's very, very, very commonly used now. And that's a char. So each one of these is a char variable, but if you use the string class, which is provided by Java, then it puts them all together and you don't even need to worry about them. You can access each one individually. This string consists of 7 characters. However, the position of the first one is called 0, the position of the second one is called 1, etc. So the last one, the 7th one, is in position 6. Please remember that, because that is a typical exam question. Now, string contains a whole load of methods which are incredibly handy. You can find out the length of the string, that would return 7 for the last one. You can change it to lower or uppercase. You can find out what a specific character is. If I pass in 0 into that one, it'll give me A. If I pass in 6 in there, it'll give me G. Okay, I can find out what it starts with, whether it's got a prefix, and I can find out whether it contains a character or a series of characters. Here's a very, very quick example of how I might use one of those. You'll be using these later on in the Java first steps in Java as you repeat yourself and change things to uppercase and lowercase. This will be a solution to one of them. You've got some text you want to change, you can print it out, then you make another string and you make that string equal to the text dot to uppercase, and you print that out again. Dead easy. Something that previously you would have had to write a big method for that goes through and looks for the equivalent uppercase character for each one. This one is really, really good. Again, I'll leave you to look through. Here are a couple of important ones. Substring divides a string up and returns you part of it. So this one, substring of 2, 5, returns wi. So if I look up our w space I, position 2, 0, 1, 2, to position 5, 0, 1, 2, 3, 4, 5, stops at 5, so it returns w space I. Does the string start with the? Returns a true. Index of is returns 4, because is in the 4th position, 0, 1, 2, 3, 4. Okay, you can go through these and look at them as needs be. Most Java programmers know 10 or maximum 20 of these. but you can find a whole load of stuff there. And the place you look to find what these mean and what they do is in the Java doc. So if you Google Java doc string, this will bring up all the documentation and examples for this. Of course, you've also got tutorials point, Stack Overflow, and all of the other help sites. Okay, we're looking now at looping, or thinking iteratively, as the IB call it. The first one that we need to know about is the for loop, and this is when you repeat something a fixed number of times. So we're pretty sure, reasonably sure, that it's going to repeat a certain number of times. We use this loop. For example, I want to count from 0 to 9. I say for, and this inside brackets I have a condition which tells Java how many times this is going to repeat and when it's going to stop. So I'm going to go through that condition now. If you look up here, the first one before the first semicolon, that's the initialization, which you should know by now, initializing a variable. So you're declaring an int I and you're initializing it to 0. Okay, so after the first semicolon, there's the condition. So this is the condition at which the loop will, while it will still continue. So the loop will still continue while I is still less than 10. Great. And then we've got the increment. So each time you go through the loop and repeat it, what happens? And I said I is going to be equal to I plus 1. I increase I. So in other words, I is going to start off 0. This loop is going to continue while I is less than 10. And every time it goes around the loop, I is going to increase by 1. So in other words, this will go from 0 to 9. The body will repeat 9 times, 0 to 9, that should be 10 times. I'm just going to edit that while we're here. It will repeat 10 times. 1 second, there we go. Because the first time will be time 0 and the last time will be time number 9. There we go. Okay, so you can have a for within a for. For example, if you had an outer one that repeats 10 times, an inner one which repeats 20 times, then whatever code you put in the center here would repeat 200 times, 10 times, and for each of the 10 times it repeats 20 times, so 200 times. Programmers try to avoid nested loops, but in some situations it's quite handy. Another type of loop for when you're not sure when something is going to end or how many times you're going to repeat it is a while loop. Now a while loop evaluates a condition before it begins. So in other words, before you begin your code, which you would put inside here, it asks, are lives greater than 0? And if lives are greater than 0, then it will do this code, and it will continue to do this code until lives are equal to 0 or less. If I get halfway through whatever long statements or long pieces of code I put here, and lives variable changes, it won't automatically stop. It'll continue to go down the loop, and it'll only reevaluate it when it jumps back up to the start. So every time it begins this loop, it'll reevaluate. Is lives greater than 0? Ah, it's not. Okay, I won't do this then. I'll come down here. There's a slight variation on this type of loop, which is called a do-while loop. Now the difference is that the do-while loop will always happen at least once. So whatever code you put inside here will always happen at least once, because if you think about it logically, it goes through here, it does all of this, and then it only checks and evaluates whether it should repeat it at the very end after it's done it. Okay, so that means that it will always do it once, but it may not do it more than once, and you don't know how many times. It'll continue to repeat it until, in this case, lives is greater than 0. Along with loops, there are two interesting words that you can use, break and continue. For example, I have a loop here, and if something is true, I'm going to break. So I think that I'm going to count up to 10,000. I'm pretty sure that's going to happen, or reasonably sure it's going to happen. So I'm going to put, from 0 to 10,000, I'm going to use a for loop. But inside there, if a certain condition is met, I'm going to break. I'm going to jump out of that loop. So for example, if I find my secret number, I'm counting from 0 to 10,000. If my number is equal to my secret number, I break. In other words, I stop there. I jump out until here. So that's handy in a situation where you want to cover a complete range, but on a certain circumstance or certain thing is true, you want to stop. You would use a break there. And I guess the opposite of that would be a continue. In this situation here, imagine I've got a huge program in the middle. I'm going to count from 0 to 10,000 again, and I'm going to print out each of these numbers. But if the variable I is equal to ignore this number, I'm going to continue. And what that means is it doesn't go down here, it jumps back up and starts the next iteration of the loop. So normally it goes like this, round and round and round, but whenever I is equal to my number, it hits continue and it just goes back up here without printing, without doing the print.